Dayton and those people, he developed the atomic structure item is like a solar system. The solar system is right in here is the sun, and then they have the different planets surrounding the sun. So that's this is the solar system model. And then they're using this model to generating the atomic model. So what they say is right here is the nucleus, in which case a lot of charges, positive charges or a neutron. And here is the orbit, and the electron surrounding here, and then a lot of electrons have a different energy level and so forth among them. So this is the atomic model, and it takes a long fight, and then the calculation, and then finally this is formalized, and we do a lot of experiment on it. After we are convinced this is the atomic structure, and then we develop what we call the atomic called energy level. Each electron have an energy level, E1, E2, E3. And then somebody like my professor at Cal State Norwich, back in 1960, 1958, 19 something like this, they all studied how the electron jump from the higher level down to the lower level and meeting the photon. And then they study what we call spectral analysis. At the back of your classroom, there's a chart there. The hydrogen have one electron, and this electron jump up and down and emit certain spectral line. And they do a lot of analysis on this. And then lo and behold, that Einstein stirred up the people's interest, saying one thing is there's a possibility of light called light amplification of stimulating individual or emerge to try to build a laser. Laser is a word according by light amplification by stimulating emission of radiation. And they prove the existing of stimulating emission of radiation existing, and then after that they try to build this. In 1960, the first laser was built. 1960, the first laser was built. It's built by successfully by Cat Mammon at Hughes Aircraft Company near the Malibu. And my teacher at Cal State Norwich was one of the research down there. And he wrote a first book in laser physics, the first book in laser physics, and he published in 1964. So at that time, I'm a student going to Cal State Norwich. At that time, the Cal State Norwich doesn't call that. They call San Fernando Valley State College. So the first initially, I feel very uncomfortable to go to San Fernando Valley State College because that school is small. And then I come from the big university like National Taiwan University. You know, we all physics students walking around like this, show everybody, especially when we go to English class and Chinese class, right? So we show off. We have a physics book, and where the slide rule is very long. The slide is about that long, right? So we carry the slide rule like a gun, right? So like this. Why? Because all the students at those days, especially female students, they like to come to United States, right? Who got the most chance to come to United States? We are. What they call physics major. My classmate, total number of classmates about 50, 45 students get PhD, and 45 students are in the United States. So only there's 5 students left in China, left in Taiwan. Anyway, that is the glory of lasers. And back in 1966, 68, because I studied under this particular teacher, I got a fellowship, 4-year free for go to study lasers. And my father slapped on my face, so I had to go to work. So I didn't go to PhD directly. That's the best thing maybe happened to my life. Otherwise, I just studying like my classmate go to the very cold area in Canada. Anyway, that is about this solar system model atomic structure. And after this, we do a lot of experiments to prove that it does indeed that way. We using electron microscope to observe the atomic structure, and then find this conclusion. Now, before this atomic structure, before this laser occurred, by the way, laser is still very popular, and then right now the technology moved to LED, light emitting diode. Next Wednesday and Thursday, I go to the conference to study, to learn about LED. LED, first laser. From laser, nowadays, move to LED. And then another technology is coming, in case you want to know, is called anode technology. So after the anode technology come through, the next one is go to femto technology. Anode technology is 10 to the minus 9. Femto technology, in which case my classmate is specialized in 10 to the minus 15. Okay, so all this, if you are in the industry, anode is the keyword. In a few years later, femto is the keyword. Of course, as far as manufacture go, about 10 years ago, laser is hot. Right now, LED is hot. So if you are moving in the technology side, watch this kind of development. Okay, so before laser, before LED, so what we going to use gravitation law? Then come to the section. Kepler's law is specialized in what? Kepler's law is related with planetary motion. So what Kepler's do is using the Newton's law or gravitation law to derive or explaining the planetary motion. And he using all this to do it. So the first, based on his study, he using gravitation law or plus the advanced math, differential equation, and so forth. He kind of developed 3 laws. The first law is called Kepler's law. First law. On Kepler's first law, what he says is each planet is planet in the solar system, move in an elliptical orbit. Now, this theory and derivation is occurred at the junior level classical mechanics. So we're using differential equation and develop the orbit of a moon or the orbit of Earth surrounding the sun. Turn out to be, the orbit is elliptical. In which case, the sun is here and the Earth is here. This is Earth. Is elliptical. So we do some approximation so that we can explain the, for this case, we always assume the orbital speed, orbital locus for the Earth is circle because it's easy to calculation. But in reality, it's elliptical because right here, if the sun, if the Earth is on here, the sun on here, you guys probably don't know. When the Earth is closest to the sun, to us, it's very cold. When the sun was close to us, in Earth, in North Hemisphere, are very cold. And the sun is further away from the Earth. At this location in North Hemisphere, we are very hot. This is the summer, and this is winter. A lot of you probably know the answer, right? Because the sun, the Earth is tilted in certain way, so the sunlight was not directly shining the North Hemisphere, so that we get less sun energy. So. To reach to here in the winter. But in here, somehow the Earth is tilted so that the North Hemisphere is facing the sun directly. So in this case, we get very hot. Okay, this might have occurred. You need to know due to the fact that for the MCAT,